Hello everyone. Today we will have session on 6G, that is IMT 2030 framework by ITU. IMT 2030 is International Mobile Telecommunications 2030. This is the name given by ITU for 6G. We will talk about the vision and framework of IMT 2030. So before we talk about the framework and vision of 6G, let us first have a look at ITU and its sectors. So ITU has got three sectors. The first is ITU-R, ITU Radio Communication Sector. Second is ITU-T, that is ITU Standardization Sector. So they make standards in this sector. And the third is ITU-D, that is ITU Development Sector. So our focus is on ITU-R because the framework and vision of 6G is actually created by ITU-R. So in ITU-R sector, ITU Radio Communication Sector, the mandate to them is management of radio frequency spectrum and management of satellite orbit. What is of our interest is one of their mandate to develop framework and vision of upcoming mobile technology. Our today's discussion is around this. Okay, and finally they developed requirement. Here requirement means radio performance requirement of upcoming mobile technologies. So we'll focus today on framework and vision of 6G. Now let us look at ITU-R structure because there are multiple activity which ITU-R does. So there are certain activities divided into different groups. So ITU-R structure is, it has got various study group. So study group 1, for example, is for spectrum management. Study group 3 is for radio wave propagation. We don't have study group 2, that is some sort of discontinued. Study group 4 is for satellite services. Study group 5 is for terrestrial. Study group 6 is for broadcasting. Study group 7 is for science services. And one we have coordination committee for vocabulary. So these are different study group. Our focus today is on study group 5, which talks about terrestrial service because mobile communication or IMT, International Mobile Telecommunications, comes under terrestrial service. Our focus is study group 5. Now the study group 5 also have multiple working parties for different work. For example, working party 5A work on land mobile service above 30 megahertz. Working party 5B works on maritime mobile services. Working party 5C works on fixed wireless system, HF, etc. And finally, what is of our interest is working party 5D, which work on IMT system, International Mobile Telecommunications System. So our interest is here. So basically ITU-R study group 5, under them working party 5D. This is the working party which is responsible for activity which we are looking at. So working party 5D is responsible for overall radio system aspects of the terrestrial component of IMT, International Mobile Telecommunication Systems, comprising the current IMT 2000, which is 3G, IMT Advanced, which is 4G, IMT 2020, which is 5G, and now IMT 2030, which is 6G. So all these overall radio system aspects are decided by working party 5D under study group 5 of ITU-R. Now let us have a look at timelines of evolution of 6G or IMT 2030. Different steps are involved in development of a technology. As we see that one technology to other technology in mobile sector takes almost 10 years. So what are those steps? So let us have a look at that. So this is the timeline for 6G as defined by or as given by ITU-R working party 5D under study group 5. So it all starts with creating the framework. So as you can see the timeline from 2021 up to 2030, so almost 10 years timeline is given. So initially we define vision and framework. So that, and there are some other steps involved. So almost 1 to 3 years, it's a 3 year cycle. So as far as framework is concerned, working party 5D has decided and it is yet to be approved by their study group, that is study group 5. Once this is done, uh, there are certain research targets also given. So after these 3 years, ITU will again work on requirement. Requirement here is the key performance requirement of the 6G radio. They will define in a document. They will also release a document where they will define evaluation criteria. So basically all other SDOs, standard developing organizations like 3GPP, it say they will develop a candidate technology and then they will submit to ITU for approval. So what should be the evaluation criteria? So that evaluation criteria is defined in this cycle. So this is also a cycle of 3 years, 24 to 26. And hereafter, all the standard making organizations would parallelly be working out a detailed specification of the candidate technology of 6G as per requirement of ITU. And that they will submit to ITU for approval in a standard evaluation templates. So this cycle is evaluation and consensus building. So once consensus is arrived, this will get converted into specification, and finally with the approval of member state, it will be published as a standards or recommendations. So there are various aspects involved in all these cycles, and it takes almost 10 years. So by 2030 we'll have 6G, or maybe 2029 it will start coming, and 2030 it will be really be coming into the market. So as we discussed that the vision and framework for IMT 2030 has already been decided by working party 5D and it will get approved in study group 5 next meeting. So what are those vision and framework as defined by ITU so far? So there are 4 steps involved in or there are 4 part of the framework of 6G or IMT 2030. So they are, first is the future technology trend of IMT 2030. What are different technologies getting evolved? Second is what usage scenarios IMT 2030 is supposed to support. And then we will have different key capabilities or radio performance requirement of IMT 2030 to support these usage scenarios. So they are correlated. And finally, this framework document gives consideration of ongoing development. So as far as technology trend is concerned, the future technology trend is concerned, ITU has had already released a document called M.2516 in November 2022 where they have discussed all the future technology trends which are available today or which are known today, on which technology work is going on. Now the next is defining the usage scenario. So in 6G, six usage scenario has been defined. 6G has six usage scenario. Three of the usage scenarios, they have done extension from 5G. So in 5G, you might remember this triangle diagram where three usage scenario, that is enhanced mobile broadband, hRLLC, ultra reliable low latency communications, and MMTC, massive machine type communications, are defined. EMBB, hRLLC, and MMTC. So these three are already there with certain enhancement. In addition, three more usage scenarios are added. So that means from a triangle we have gone to a hexagon. So how these extensions out of the six usage scenario, the three extensions from 5G are like EMBB has now immersive communications, MMTC is now massive communication, hRLLC is now hyper reliable low latency communications. In addition, three new has been added, which is ubiquitous connectivity, this one, ubiquitous connectivity. Then we have integrated AI and communication, integrated AI and communications, and finally integrated sensing and communications. So now sensing, which used to be a different network, is going to be part of the mobile network also. In addition to the six usage scenario we talked about, they have also talked about a overarching principle. The outer circle which you see is overarching aspects, or we can say design principle, which are applicable to all the six usage scenarios. What are these? These are sustainability, connecting the unconnected, security, privacy and resilience, and ubiquitous intelligence. So AI accessibility for everyone. Now, as we have discussed various usage scenario, six usage scenarios and four overarching principle. Now we'll talk about 6G capability or the key performance requirement of 6G radio to meet those six usage scenario and also the overarching aspects or design principles. So what are these capabilities? So if you look at this palette diagram, this gives the 6G capability. 9 capabilities in green color what you see are enhanced from 5G, and 6 capability which you see in blue color are the new capabilities. So in total there are 15 capabilities or key performance area defined for 6G. So now we will kind of correlate these capabilities into the usage scenario, the 6 usage scenario defined, how they are related to each other and how they will support, how these capabilities will support the usage scenario. Let us have now look at immersive communication, which is extension of EMBB in 5G. So what are different key capabilities which will support immersive communications? Starting with peak data rate. So peak data rate as defined in 5G was 20 Gbps in downlink. In 6G it is defined to be 50 Gbps, then it will evolve to 100 Gbps, and then finally it will evolve to 200 Gbps. So it's not a single target defined in 6G. These are different targets defined which will be achieved over a period of time over it evolves, and these are in fact the research target. So actual requirement document is yet to be released. In the framework they have defined these as the research targets. So generally this will get freezed. The next parameter, capability parameter for immersive communication, is user experience data rate. When we say user experience data rate, we are talking about data rate which we can get even onto the edge of a network. That means some sort of minimum guaranteed data rate which one will get always. So this is defined as 3 Mbps and then finally 500 Mbps. In 5G it was 100 Mbps. So 3 times and 5 times enhancement is there in 6G. The next parameter is the peak spectral efficiency. So what is spectral efficiency? In 1 hertz of the frequency, how much data can be transmitted? So in 5G it was 30 bit per second per hertz of the spectrum. For every hertz there was a 30 bit per second. In case of 6G it is defined as 45 bit per second per hertz, that is 1.5 times, and then 90 bit per second per hertz, which is 3 times compared to 5G. So spectral efficiency is going to improve in 6G up to 3 times. And the next parameter is area traffic capacity, that is in 1 square meter of area how much data can be pumped. So for 5G it was 10 megabit per second per square meter. In 6G it is defined as 30 and 50, that means 3 times and 5 times, it will go up to 5 times compared to 5G. The next parameter of immersive communication can be considered as mobility. When we travel in a high-speed train or bullet train, our mobile should work. So that's the mobility. So 5G it was defined to support up to 500 km per hour. In 6G will go up to 1000 km per hour. So it will almost double. And then we will talk about massive communication. So the second usage scenario, which is extension of MMTC, is the massive communication, and we'll look at what are those key performance requirement or parameters which relates to massive. So now let us look at important radio performance parameter for massive communication. So in case of a massive communications, all those sensors, machines, objects would connect to the network. So there will be a huge number of such machines or such objects connecting to the network. So connection density is that in 1 square kilometer area, how much such devices can connect to the network. In case of 5G, it was 10 to the power 6, that is 1 million devices per square kilometer. So that we are continuing in 6G, same 1 million devices per square kilometer, but we will evolve to 10 to the power 8, that is 100 million devices per square kilometer. So from 10 to the power 6 to 10 to the power 8. It's a huge enhancement. In addition, these massive communications would definitely require energy efficiency and will also require the deep coverage. That means our network would work on lower frequencies so that we have a deep coverage. Now let us talk about hyper reliable low latency communication, that is hRLLC. That is the third usage scenario corresponding to URLLC in 5G. So for hRLLC, the parameter is latency. So in 5G, we had seen that for URLLC, the latency can go up to 1 millisecond. Here we have target starting from 1 millisecond itself and going up to 0.1 millisecond. So 10 times improvement finally. These parameters can also be considered as the research target, and while when ITU will issue the technical requirement performance parameter, these are in the document, they can actually refine. So these should also be considered as a research target as it is part of the framework document. The next parameter for hRLLC is the reliability. When we say reliability, what we mean is that if I transfer some bits to you, how many bits you have received correctly and how many bits you received in error. So for 6G, they have defined as to be 10 to the power minus 5 to 10 to the power minus 7. What does that mean is that if I just take 10 to the power minus 7, that if I transmit these number of bits, that is 10 to the power 7 number of bits, only one bit of error is allowed. Otherwise, it will not be 10 to the power minus 7 kind of. So these are bit error rate kind of, or packet error rate. So that means we are talking about 99.99999% of reliability. So that is 79 kind of reliability. Okay, the next parameter which you can think of hyper reliable low latency communication is the positioning, because positioning is also some sort of reliability, because you have to, I mean, you'll have various use cases around it for industry, for other sectors. So positioning is also a reliability parameter, you can say. So the accuracy of positioning, we are talking about 1 centimeter to 10 centimeter kind of accuracy. Finally, we can say 1 centimeter accuracy we are targeting as part of 6G. Now that we have completed the 3 usage scenarios which were extension from the 5G usage scenario, now the other usage scenarios are new. For example, ubiquitous connectivity. So what is ubiquitous connectivity? So basically it talks about access to communication services for users in a desired service area. So basically we are talking about coverage. This one, if you see this coverage, this blue part. Positioning we have discussed in the previous one. So ubiquitous connectivity is access of connectivity for everyone and everywhere. That is the ubiquitous connectivity we can consider. The next is integrated sensing and communication. So the new, out of the new 6 capabilities, one is integrated sensing and communication. So what is it? So sensing capabilities, when we say, it means range, velocity, angle estimation, right? So we should be able to sense range of a particular object, velocity of a particular object, or the angle on which it is moving. We should be able to detect a particular object, identify a particular object, that yes, this is this particular object. Then localization, imaging, mapping, these all are part of sensing. So we want integrated sensing in the communication network in addition to the human communication or machine communication which we had been talking about. The next is integrated AI and communication. So this is some sort of, we can talk about AI related capabilities here, which is mentioned here. That what should be AI related capabilities. So basically, the first we are talking about distributed data processing. So now the entire network is some sort of disaggregated. We have edge, we have core, we have other area of the network. So the data processing will happen across the distributed network. Then the AI, the distributed learning, we are saying that AI in the device, AI onto the edge, AI onto the core. So it is a distributed learning, distributed AI learning. Then we are talking about AI computing, AI model execution, AI model interface, and so on. So we are talking about native AI capability into the network itself, into the radio itself, into the core itself. The most important other capabilities, let us talk about. Out of the six other capabilities, one is the interoperability, which all of us know that very important, that the system should interwork with each other. So interoperability, in the definition given by Working Party 5D, is that it refers to radio interface being based on member inclusivity and transparency so as to enable functionalities between different entities of the system. So we understand interoperability, and here, since Working Party 5D is defining, so they are only talking about radio, whereas this is applicable to end-to-end system. Now that we have discussed all the usage scenario, all the six usage scenario, and 15 capabilities, 15 different capabilities of 5G, 6G. Now let us look at that overarching aspect or the design principles, which were four in number. So these are sustainability, connecting the unconnected, security, privacy, and resilience, and then ubiquitous intelligence. So design principles are security, privacy, resilience, ubiquitous intelligence, sustainability, and connecting the unconnected. Okay, so what is security? If we talk about security, so security is nothing but confidentiality, integrity, and availability. So these three are the major aspect which one has to manage. As part of privacy, we have to protect an individual personal data or information, and also individuals should be able to determine that whether, when, how, and for what purpose his information is collected and processed by others, and for how long it is retained. That means that if I have given my personal data for any purpose to any organizations, they should, I mean, as and when that data is used, I should be informed, or without my consent, data should not be used, and I should have a right to request deletion of the data, or how long they can retain the data. All these should be part of privacy. And resilience is that in case of a problem or the failure in the network somewhere, the system should continue to work on the backup defined. For example, primary source of power is cut, then it should continue working on secondary source of power, or which may not be as good as or as required as the primary source. So these are security, privacy, and resilience part of overarching principle. And then we have sustainability. Sustainability, as we all understand, is how we can make our system energy efficient, how we can minimize energy consumption, how we can minimize use of the resources. So these are sustainability aspects of the technology, in the sense that whether you go on 5G and 6G, you should think about the sustainability part also. So what next? So now ITU will firm up these requirements. So these, as I said, these are kind of a research target. So they have to firm up and create a key performance requirement document. And then along with that, they will also, ITU will also release a evaluation criteria. After that, all the SDOs, standard developing organizations like 3GPP, ITSE, IEEE, TSDSI of India, so on, are free to develop the technology against the ITU requirement and submit it to ITU for approval. And ITU finally evaluates and approve or not approve, whatever may be the case, a particular technology. So with this, we have come to the end. So thank you, thank you, thank you.